So we're going to wrap up our coverage of the ImageStreamGang case study by talking about how to implement this collector we talked about earlier, which is called the StreamOfFuturesCollector. And it's going to wrap the allOf method so that things will work with the JavaStreams framework in a seamless way. So this is going to be, the first part will be sort of a recap of what we talked about earlier, so I won't spend a lot of time on it. The StreamOfFuturesCollector wraps the allOf arbitrary arity method so it works seamlessly with the JavaStreams framework. So we have a little wrapper. And what this does is it converts a stream of completable future objects to a single completable future that triggers when all the completable futures are complete. And of course, this StreamOfFuturesCollector will implement the collector interface. And we're going to take a look at how that gets used here in just a second. Remember what a collector does. It accumulates the elements in the stream and puts it into something called a mutable result container. And that mutable result container can be defined using these various factory methods that are part of the collector interface. So it therefore provides a nice, powerful wrapper for some otherwise complex code. So the visual metaphor here is we have the Gordian knot, which is complexity, and we've made it more powerful. I'm not really sure if that's the right metaphor, but it was fun doing the Photoshop for that. So let's take a look at the implementation of StreamOfFuturesCollector, or StreamOfFuturesCollector. So StreamOfFuturesCollector implements collector, and collector defines three parameters, three generic parameters. The first is the type of elements in the stream, which in this case, of course, are completable future to type T, because we want to make this thing a generic class that can be reused. The mutable result container is the second parameter, which is a list of completable future to T. And the third parameter is the result type of the final output of the collector when all is said and done. Everything in the stream has been processed, and we've finished the collector processing. So this will be going to be returning a completable future to a stream of T. And the stream of T part here is pretty cool and interesting. The stream of T parameter in StreamOfFuturesCollector is slightly different from the list of T parameter that we used in our previous discussion of FuturesCollector, which we probably should have called listOfFuturesCollector just to be consistent. But the FuturesCollector we talked about before returned a completable future to a list of T, and this is going to be a completable future to a stream of T. And you'll see why we need to do that, because we end up wanting to use the results of this whole thing as a stream, and if we return it as a list, we'll have to turn it back into a stream again, which would be excessive conversion overhead. So here's what the supplier method looks like. This is a factor method that returns a supplier that the JavaStreams collector framework uses to make the new mutable array list collector. So you can see here that we return a constructor reference that makes a new array list. So nice, clever little use of method references and constructor references in the context of the supplier factor method. What the type of this thing is going to be, it's going to be a list of completable futures to type T. So we're going to have the array list store the array list will be a list of completable futures to type T. We then have the accumulator, which is also a factor method, and that returns a so-called byConsumer, which has two parameters. And the JavaStreams collector framework will use this to add a new completable future in the stream as it is absorbed into the stream, as it is going to ingress into the stream. And we're going to use that in order to store it in the list that's the mutable result container. So we just say list : add, which is a method reference that conforms to the signature expected by consumer. And this method, the accumulator method, and the add method for that matter, is only ever called in a single thread. So we don't need to lock anything. We don't need to put any kind of locks in the code. We then have the combiner method, which returns a binary operator that merges two partial array list results together into a single array list. And as you can see here, what we do as usual is we take one list of completable futures and another, and during the merge phase, we combine them together by adding another to the end of one and returning one, which, by the way, will, to some extent, preserve the encounter order for sequential streams. This method is also only called in a single thread, this combiner, so no locks are needed here either. Now, it turns out this particular approach is only needed for parallel streams, and we don't use a parallel stream here, but we need to add it anyway. And the final method here, which is really the cool one, I take it back, not the final method, the final important key method, is the finisher method. And that's going to give us back a function that the JavaStreams collector framework is going to use to transform the mutable result container that's using for intermediate stages, which is this array list, into the final result, which will be a completable future to a stream of elements of type T, which in our particular example that we've been looking at will be these images, but could be anything because it's generic. And this uses the arbitrary arity method, and it works this way. We take futures, which is this mutable result container. It's that list of completable futures. And we turn that into an array by using the toArray factor method on the futures list. And this new completable future sub-0 thing is just there to tell it what type to make this. It's kind of goofy, but that's the way it works. So then we take the array of these completable futures, and we call allOf, and that returns one completable future that completes when everything else completes. We then use the completion stage method, then apply, and when all the computations are done, this action that's registered here will be called back. And you can see what that action does is it turns the list of futures to a stream of futures, and then it calls the map intermediate operation to join all the results. And this is simply turning everything from a stream of completable futures into a stream of completable futures of elements of type T into a stream of elements of type T that have been completed. And as I always like to say, there's no way that we would get to this point if all those other computations were done. So when everything is finished, we join. Join never blocks because we're already finished. It's just there to convert the type from a completable future of T to T. So we end up with a stream of T. And what gets returned here from then apply is a stream of, a completable future to a stream of elements of type T. So remember, these completion stage methods always return completable futures. So we get back a completable future. There's no easy way around that, which is fine. There's no easy way around that without calling join, I should say. And we don't want to call join. So what we're doing here is we're using then apply, which returns a completable future to a stream of T. And I think I show here that what happens is that when collect returns that single completable future to a stream, and then we stream these things out here. A couple other quick methods. We have the characteristics method that just says we don't care whether the ordering property is maintained. We don't care if encounter order is maintained. And then finally, we end up with the toFuture factor method that makes a new stream of futures collector. It makes a new instance of StreamOfFuturesCollector, which is what's used here to wait for everything to finish up. Then apply is called only after the completable future returned from collect complete. So it's that nice reactive way of waiting for lots of other stuff to finish with only a single point. And I should use the word waiting loosely here because it's not really blocking. It just is triggered when everything else is done. So that's the end of the StreamOfFuturesCollector discussion. I should point out that your assignment 3 has an int_stream futures collector, which is very much like this one, except rather than returning a stream of elements of type T, it returns an int stream. And that works, of course, because your program expects to have a stream of ints at that point. But the code is almost identical. It just uses int stream to wrap everything up at the end, as opposed to returning a stream.